And welcome to Ladyada.
Hello, everybody, and I hope you're having a good Memorial Day weekend. It's a nice long weekend. Don't forget, Adafruit is closed on Monday, and there's also like no shipping and delivery. So hopefully, you didn't need anything delivered on Monday. But if you order on Monday, it'll ship Tuesday morning. You'll get it on Wednesday. Doing some stuff at my desk. Let's just jump right into it. So first up, let's go to the computer. So a few weeks ago, 2 months ago, we did a great search on temperature humidity sensors, and we found this really sweet sensor, the HDC3022. It's like the 32X. The 22 version has a nice Teflon cover on it, which I'll show if we go to 322. Okay, 1 second. Yeah, so this sensor, it has like you can see this like white covering. You don't remove that. That's actually kept on, and that lets the humidity be sensed, but it keeps dirt and dust out of the cavity. So what I got on my prototypes. I got the HDC 3021, but the final version will be the 22, which has the cover. I got my prototypes. So if you go to the overhead, here's my proto with the, you can see there's no Teflon. So this is the HDC 3021. So you can see the cavity there. Just a little bit of cutout, not a huge cutout, but like enough just to give it a little bit of thermal isolation. No level shifting needed because it's actually a 3 or 5 volt compatible chip, and I'm plugged into my Metro. And then if we go to the computer, I have the data coming out of it. So this library was like, it was a little bit of a headache. I mean, it was very long. The sensor does a lot. There's like NIST tracking, and there's a lot of alerts, and like it doesn't use registers, it uses commands, and like sometimes the commands have a CRC and sometimes it doesn't. So I used GPT-4 to help me with it. I uploaded the data sheet, and then told it like, okay, let's get started. And then it just took a really long time. Actually, it took like three days in a row to write all of the commands and instructions. There's just like it's just very funky. But we did get it eventually done. And so now I've got this, and I've also got the status register printing, and you can set up alerts. So if I breathe on it, you'll see the humidity goes up, and then it's like you get a high tracking alert. So this, I got both continuous readings and, triggered mode, force mode, working. So I think this will be a really nice sensor. What I like is that like, it doesn't seem to be very affected by self-heating. Like it says the temperature is like 24.5 degrees C, and it's room temperature in here. Like it really is like 25. So, I really trust it. I think this is a good sensor. So I think, for a lot of people, the HT20 is perfectly fine. But if you want something a little nicer, the SHT45, and then maybe even nicer than that, this HDC3022. Meanwhile, Carter and I are still working on the plant sensing stuff. So nothing really new going on with it. I've been logging the data, and like it's okay, but it's like it's definitely like the capacitive sensing I'm using definitely has like this jitteriness, spikiness sometimes. I think it depending, on how you do the capacitive reads. This is in Circuit Python, so might be a little better in Arduino because you can control it a little better because it's like you can code the timing a little tighter, and I'm not dependent on whatever is built into Circuit Python. But we're also looking at that gigantic thread I talked about last week, like social network for soil moisture sensing. And we might implement the frequency detection system rather than the RC delay timing system. Sorry, the RC peak to peak voltage change, not the RC uh, frequency like sawtooth thing. So it's like two different ways of doing the capacitance measurement, but having a higher frequency as well. So we're working on that. Nothing new there yet, but I'm still we're just kind of letting things sit. And he's also, the problem is when you have a new circuit and then you put a plant on it, you have to wait like 3 days to see like how it changes. So it's like a slow growing project. Okay, next step on the overhead. These boards came in. I think I chatted about them before. I actually needed these for like a different project. I was building a tester and I had used this breakout board that like let me disconnect the power line, and it got discontinued, and then like you can't get any more. And I was like, well, I was like, I really want a board that has like some nice, you see how these like switches are really pointy, so it's like they're easy to turn on and off with your fingernail. So it's like a really nice quality dip switch. So 4 switches for the power, data, and ground lines on USB, and then also have the breakouts. So this is good for testing power, or like if you want to disable just the data lines, or you want no ground, like you can pick and choose which ones you want to have on. But I was actually using it to test this prototype, which you guys might remember from like 2 months ago. I just had to like get the components, and everything just got delayed a little bit. So this is the USB-C plug. So what's cool about this is I think, this could let us do Trinkies or projects that like plug directly into a computer, which could be kind of neat. So USB-C plug, and then because it's a plug and not a socket, you don't get as many, and also this is a simplified version, you don't get as many pins. You only get the CC1 pin, because apparently the socket is what detects the orientation, not the plug. I don't know. That's what it is. So the data lines, I've actually been testing this by soldering onto here, because what's really nice is I can use it for host or peripheral. So I plugged this into, my Mac, and then I plugged in a USB-A device and it enumerated. And then I tried plugging this into like a device, and then this can plug into, let me see if I have, like I can plug it into here, and then, verify that this is working. And then I think, hopefully, live demo. Yeah, but if you go to the overhead, the computer, it's still working, like the data and power is coming through. So I know that the plug is good. And I tried like all orientations also. So it's good. So I'm going to get this connectors, and I'll have this breakout in the shop soon. Connectors are a little bit long lead time, but I'm sure I'll get them eventually. So it's always kind of fun to test 2 things at once. I was like, oh, like, how am I going to test this plug? I was like, oh, am I going to have to like wire up some like DIY port? And it's like, oh wait, I'm going to use my little thingy that I designed for previously. So these thingies are handy. Especially I like that it's like, it's a flippy floppy. It's like host or device. You can swap, because USB-C can do either. Okay, got the USB-C. Okay, and then lastly, I am still crunching through a bunch of stuff that, during the part shortage. This was affected by the part shortage, but then I was like, oh, I was like, let's not get PCBs. And then it was time to get PCs. I was like, oh, I want to redesign this. So the RGB Shield, this is ancient. This is the old 2x13 connector. This is how old this board is. And it came from this RGB Shield kit that I had for Arduino. This is a really old product, and it could be used with, this is blue and white. Yeah, this one. So you can use RGB 16x2 character LCDs using an I2C expander. It's slow, but for many use cases, it's just fine. And again, you can see this used to be a through-hole kit, because I think actually I designed this before we had a pick-and-place machine. It's an old product, or like before we had a pick-and-place machine that could handle large PCBs. And like during the shortage, I was like, like people are kind of like, people aren't really into building kits as much anymore. So I wanted to change this design from through-hole to surface mount. So let's go to the overhead, and you can see the updates. This is the final design. So the thing is, I wanted to keep everything as much the same as possible. So it still has up, down, left, right, and select buttons. the 16-bit MCP 23017, which like, you know, during the part shortage, they released an errata that like 2 of the pins can only be outputs, but like thankfully they're connected to the LCD, so they're not input pins, like just coincidentally. So luckily this design doesn't have to change. Reset button and then a contrast pot, and then it now uses also the I2C pins over here, and you can bridge it to use A4 and A5 for very old Arduinos. And you can change the VIO, although I default to 5 volts because 99% of the time it's fine. And then hit reset, and then, you know, you can, I just tested the RGB, you know, all the different colors. Purple, beautiful. So this design is done, and then I'm going to redo the hat version, the Raspberry Pi plate hat. I don't think a lot of people buy them, but like I feel like I should stock it just for historical sake. Okay, how are we doing on time?
Good. You're up to 11 minutes.
Okay, great. Let's go to I think I covered everything. Yeah, that's kind of what I'm working on. All right, let's go to the great search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thank you, DigiKey. Every single week, Ladyada uses the power of engineering to help you. Yes, you find things on digikey.com. Ladyada, what is in the Great Search this week?
Okay, so this week, let's go to the computer. I am redesigning some boards that were affected by the part shortage, and then now they're fine. But during the part shortage, I had a little bit of like a, you know, I was like, oh, if I'm going to clean the kitchen, I'm going to also clean the living room type thing, and decided I wanted to redesign this board from being a fully through-hole kit, because when I first made this board, I didn't have a pick and place, to now be a surface mount kit. So it's out of stock now, but basically it's a little shield that goes on top of your Arduino compatible and lets you connect 5 buttons, like up, down, left, right, and select, with a 16x2 RGB LCD using only 2 pins. So it's just like it doesn't interfere. You can stack on top of other shields. You can have motors, you can have, you know, Wi-Fi or whatever, and you know, or other sensors, and also display some text out. You know, we sell full color TFTs, but sometimes you just really want to have a little bit of text, and also these are like nice and readable. Especially if you want to have the backlight be like an indicator. You know, it's like, oh, something went wrong, turn it red, or something's going okay, keep it yellow or green. So I like these, like this design. So the good news is that the resistors are easy. You know, I just used 0603 or 0805 resistors. The MCP 23017, you can just use QFN or SSOP, TSOP. The pot, you just use a pot. But then the buttons, here's the thing about the buttons. So I actually don't usually use buttons like this. I usually use buttons. Let me show you the buttons I usually use. I usually use tactile switches that look like this, and they're very thin and they're flat. They don't stick up a lot. And I was tempted to use these buttons, but then I was like, oh, you know, if someone, first off, I like the sticky uppiness of these tactile switches that were used in this kit. They lift up and they have like a nice big bump, and they have like a good tactile response. And also I wanted to make it as mechanically equivalent, like moving from through-hole to SMT. I didn't want to change the design. I just wanted to change how it was manufactured. Instead of being soldered at home by people, it would now come pre-soldered. So these are common, you know, they're jelly beans. I call them the 6mm tactile switches. Again, mostly they come through-hole, but you can get them in surface mount. So let's go to DigiKey and find the equivalent of those 6mm tactile switches, but in surface mount, but the same height. I want them like mechanically the same, but just it's pick and placed. So you can start by searching for tactile switch. And they've got all sorts of kits where you get a whole bunch, but what I wanted the individual ones. So I'm going to select tactile switches. And there's a lot. You know, you can see that we're in the right place, because it's like, oh yeah, that's the thing I want to replace. And this is not what I want, but it's like, I get it. You know, this is the surface mount little flat switch, which I'm not going to use. So let's let's start filtering it out. So we want active. And we want surface mount, not right angle, like top down only. And I'm going to also select the dash, although I don't know, it's just a habit of mine. Sometimes it doesn't actually help, but I feel like it's useful. Non-illuminated, so I'm going to not select the illuminated type. And then I'm going to say in stock only. Part shortage is well over. Basically, if it's made, it's available, it's going to be in stock. Although I hope nobody's watching this from the future and then there's another part shortage. It was terrible. I hope that never happens again. Okay. So now we're up to only SMT. So this actually looks pretty promising. That looks close, but it's way too tall. That's the thing. So let's go to the overhead and let's see what height we want. So the switch has a height, and there's also like, you know, there's the body height and there's the actuator height. So this is not how you normally would use the caliper. You'd use depth mode, but it's kind of hard to show that. So like this. And the height, it's about 5-ish millimeters. So to make sure that we don't select, oh, can you go back to the computer? To make sure that we don't get like these tall boys or these short boys, I don't know. I don't know if they're gendered. We're going to select height off the PCB, and we're going to make sure that it's at least 4 millimeters and less than 6. It's like 4 to 6 millimeters, which I think will narrow it down, but, you know, give us some more options. Okay, these are looking good. Okay, so the next thing is we want to get rid of these skinny fellows here. We want only the square body ones. If we go over to the right, we'll see that this is determined by the outline. We want the outline to be, and this is actually a little tricky. See these two? If you look here, you're like, oh, that looks like the switch. These are actually different body sizes. This is 4.5 millimeters, and this is 6. So this is like a little petite. This one is also petite. It looks right. The image looks correct, but the scale is off. So the size of the switch that we want is 6-ish by 6-ish millimeters. I'll say it's not exactly 6. And sometimes it's off by a little bit. So we're going to be a little flexible. We'll select everything that's like, not this one, because that's 3.5, but like 6.2, 6.3, maybe up to 6.5 millimeters by 6. So like that whole cluster. And that gives us, you know, we're down to now 300 options. Okay. Next up, this is really close, but it's too short. Like the body's the right size and the right, you know, shape, but the height of the actuator is too short. Like you see how they're very flat against the body. And if we look at the switches I use, you see that they have a little bit more height. So these are actually 5 millimeters tall. I think we measured them. And the ones these ones, if you look over to the right, they are, let's see, height. The actuator height is 4.3. So 4.3 is too short. We want like this, which is an actual 5 millimeters. Look exactly. So let's filter out the 4.3. Let's go for 4.5 or higher. Okay. Much better. Yeah, so these are all looking much better. So now, you know, basically you can pick. There's a couple that are not quite the right style, but, you know, they just happen to match. It's kind of a cool switch, but isn't what I'm looking for. This isn't, you know, this is too flat. I don't know that the body height as opposed to the actuator height. Yeah, it's not indicated. So, you know, you just have to look at the photos. Okay. So next up, I was like, okay, you know, another thing you want to make sure is, let's sort by price. Let's see what we got, because we're making a low-cost kit. we want to get rid of, like, this looks good. Like, these are too short. I actually don't even know how these made it in because these are definitely not 5 millimeters tall. This is okay. Oh, it seems a little short. It looks like maybe it's 4 point. No, it says 5. It could be that the image isn't quite right. But these come in bag, and I don't want bag. I want them to be in tape and reel because I want to pick and place it. So I want to filter out the wow, what's this? Oh, I think there's a way that was like you could filter only though. That's a new thing. I'm discovering new things at DigiKey. Let's apply this filter. Maybe it'll. This is a new thing. Ooh, it's a new thing. This is live. We're discovering new technology. Okay, so I just filtered for only tape and reel. Oh, and then I can remove it. That's kind of cool. That's nice. Yeah. Okay. Cool. So the top ones, and what's interesting is, pre-part shortage, I also always used to say, like, look at the quantity available. That'll give you a really good hint. Like, if it's a high quantity available, it's usually like popular. It's like when you go to like the food truck and you're like, wow, there's like 20 people in line at the Washington Square Park food truck. What's up with that? It's like, it's probably pretty good because otherwise there wouldn't be a gigantic line. So if you sort by quantity available, these two are both the least expensive and also the highest quantity, like 150,000. So both are good. They look basically the same. So, I like C&K. They have a little bit more in stock. Both I think have like pretty much the same life, temperature, grading. But I think we covered CTS. So you can use either, but I'm just going to pick one. I'm going to pick this one, the C&K PTS64 in stock. Lots in stock, about 15 cents a piece. This is my pick for the Great Search.
And that's the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
Alrighty, that's our holiday weekend show. Thank you so much, everybody.
Thank you, everybody. Have a great long weekend. Of course, don't forget, Adafruit is closed on Monday, but we'll be back in business Tuesday, so we'll ship your orders then.
Bye-bye.
Bye, everybody.